All right, I think we're recording here. So this is lecture number 4. This will be the last week of Marbleslides. I did decide to take it one more week. It just works out kind of good with the layout of the schedule. Plus, developed a few more things that I think are going to kind of be challenging and interesting to try out. If you run across one of these that is overly challenging, feel free to shoot me an email or send me a message on Teams, and I'd be happy to at least, I'm not going to give you the answer, but I would be happy to give a hint along the way. And the final problem of this module 4 will be a challenging one. So even if you don't get all the stars, get as many of the stars as you can possibly get and get as full of credit as you can possibly do. All right, so the first thing I want to show you here is you're going to see some functions now where the launch point, as you see as the blue arrow here, I'm going to pull up my little pen here. You can see our blue arrow is, where's my mouse? Where's my mouse? There's my mouse. There we go. So my blue arrow, this is my launch point right here. This is going to be my launch point. Now, the trouble is when I launch here and I'm going down, I'm going to be going, both ways. So what I want you to consider on some of these is maybe I need some of the balls to go to the left and some of the balls to go to the right. And how would you go about doing that? Well, as an example, you can see down the bottom one down here, I actually just drew in a line. So I just drew in a line basically where the line is essentially just x equals 0. So it's going up and down along the y-axis. And then I just put in a domain feature here to where something like, if we're launching from 5, then maybe y will be less than 4 or something like that. So by doing that, what I did was I've got x equals 0 as this vertical line, but only from, let's say, 4 down. So it goes all the way down. Now what's going to happen is when the ball comes down and hits this, it's going to bounce this way. Some of them are going to bounce this way. It's going to be kind of random, but you're going to get an equivalent amount of balls bouncing to the left and bouncing to the right. And by doing that, you then can very easily, determine a function over here and a function over here, which these balls that go to the right can go down this way, and the balls that go to the left can go down this way. So I'll show you a demo of that here in a few minutes, but I want you at least to see that and kind of understand, okay, that's why we might want to try something like that. A circle. This is another very, very handy tool in the case of the Marbleslides, but it's very handy in the case of, the way satellites orbit the Earth, or way we might use gravity assist to launch or to propel a spacecraft or something like that, or even just kind of how centripetal force works and things like that. So this is the standard equation of a function. Let's see, do I still have my pen going? I still do have my pen going. So this is my general equation of function, or of a circle rather. But a lot of people will say, oh, a circle, that's a function, right? Well, in actuality, if you remember, we talked about functions needing to pass the vertical line test. In this particular case, if I draw a vertical line, it's going to hit this graph in 2 locations. So circle in and of itself is not a function. And the reason why it's not a function is because it doesn't pass a vertical line test. So remember what we said for a vertical, for it to be a function is for each value of x, there would be specifically one value of y. Well, I can see right here that for this value of x, I don't know what value of x it is, but negative 1.5 or something, right? There's a value of y here, and there's a value of y here. So I'm not going to pass the vertical line test. Doesn't mean we can't turn a circle into a function. We're not going to, as soon as you enclose the entire circle, it's obviously not a function, and that is the equation for it. But is this a function? So now this is the exact same equation up here. So you can see this is the very same equation we used in the previous example here, except what we did is we constrained the domain. So the domain, the values of y, I guess the range is what we really constrained. We could have also constrained the domain, but in this particular case, if I constrain the domain, I'm going to chop it in half vertically. And if I constrain the range, I'm going to chop it in half horizontally. And all we're saying is when I say domain and range, I'm saying constraining the x values or constraining the y values. So is this a function? Well, by all means, yes, this is a function. And why? Because it passes the vertical line test. So now as I draw a vertical line anywhere along this function, right, it's only going to cross that function in one location. So whether it's there or it's there, wherever I draw it, it's only going to pass. Now you might question, oh, well, when I get really, really close here, it's still only hitting in one location, but it is at the very, very bitter end of that function where it's hitting. So this is a function. So when we talk about a circle, a unique thing about a circle, whether we're using it as an arc or a semicircle or something like that, and it is a function, or whether it's not a function and it's just an equation, it really makes no difference to us. We're going to use it in all kinds of different variances. But this is the way you're going to type it into decimals. I just got to find my little guy here again. So this is the equation you're going to use. What's neat about this is it actually is fairly easy to draw a circle in decimals. You type in x minus h, and then you square that whole parentheses, and then you add that to y minus k, and you square that whole segment, and then, and it's actually not, this should be equals to r squared, not equals r squared, shouldn't be minus r squared. I wonder what I had on the previous ones. Yeah, I did have equals on the previous ones. I don't know how I ended up with minus r squared here, but this should be equals r squared, not minus r squared. And so the r value is going to be our radius of the circle. The h and k are going to be the xy location of the center of the circle. So if we looked at this function that we're seeing over on the right here, again, I got to find my little dot. Here he is right here. And I would say, well, x minus h. So I want to know where the x location is. When I see go all the way over to this looks like 3. So this is going to be x minus 3, right? And that's going to be in the parentheses here. I'm just going to take time to try to make it look pretty here. And I'm going to square that whole section there. X minus 3 squared. That's the x minus h, right? I'm going to add that to whatever I want for my y minus k. So what is my k? Well, I can see that if that was 3 in the x direction, again, this was the x direction going this way. Well, now in the y direction on this one, if I'm going this way, this being the y direction working off this one, I can see I'm up at a positive 2, right? Don't be confused. That's grid. That doesn't say negative 2. That's just grid lines that I'm seeing there. So y minus 2, and I'm going to square that as well. That's going to be equal to my radius squared. So now what is my radius? Well, in this particular case, I can see my radius is going to be this value here. This is my radius, right? And I can see I go from 3 to 2 is 1, and then 2 down to 1 is another one. So it looks like I got 2 squared is what I got. So my radius is 2 squared. So if I type this into decimals right now, this is what I would actually get, the circle that you see on the bottom there. And you can shift that function, by using the HK values. If I wanted to go in the negative direction, instead of writing x minus 3, I would write x plus 3, because it's assuming x minus h. As soon as I put a plus, that's like a double negative. So it's like a minus minus h. So the minus h then becomes a positive, or the minus k then becomes a positive. So like an x plus 3 squared plus y plus 2 squared equals 2 squared would put this thing in the completely kind of diagonal quadrant, negative x and negative y. So it would be down in, I'll just draw an arrow to it because I can't actually see it here. Oh, no, hold on. It'd be down in this quadrant down here is where it would be, where the x and the y are both negative down here, right? So negative x, comma negative y for your, or negative h, negative k for your center of the circle. In this section, you'll also encounter some blocking functions. And what a blocking function is you'll see on this particular example, I just can never find my little guy here. There he is. You'll see how this first thing is locked. What that means is I've put a function in the way here. So these 3 stars are kind of underneath an umbrella. So what you can't do is you're going to launch here. Unfortunately, you can't just draw a line at those stars because it's going to hit that parabola and it's not going to be able to get to those. So you're going to have to create some sort of other function that's going to loop those balls back up and into this into this semicircle here, right? So I've created the circle, and you can kind of see how I did it here, right? There's your y minus 2 and your x minus 1. So I can see the center of the circle is at x1, y2, and then I can see that my radius of the circle is a radius of 2. However, I limited the y values in this by saying I'm only going to graph this thing from any place where y is greater than 2. So you can see that the y values are greater than 2 only there. So that's how I graphed it. So I didn't put the stars inside of a circle. I put them inside of a semicircle, which is going to allow you still to get axis up and in there. But you're going to have to be a little bit creative in how you do that. So that's the nature of what we're going to do for Module 4 here with Marbleslides. I'm going to do a couple of quick demos in Desmos just to get you guys some examples here to look at. So I'm going to go into Desmos real quick, and I might even just go into just regular Desmos for a moment before I do any Marbleslides stuff. And so in regular Desmos, the first thing I was going to show you is we go back and look at that PowerPoint again. The equation of the circle, which was this, x minus h, y minus k. So let's do that. Let's just put one of those into Desmos real quick. Let's say x minus, well, let's say we want to put this circle right at 2, 2. So x minus 2 squared plus, in parentheses, y minus 2 squared. And then let's say we want the diameter of that circle to be 1. Then it's 1 squared. And you'll see I get a diameter, or not diameter, a radius of 1. If I wanted to make that radius bigger, I would just change that to a 4 squared. Now I get a radius of 4, so a much larger circle. And if I wanted to go 2, I go 2 and I get a much smaller circle, right? Now if I wanted this thing to shift across the y-axis over into the negative x values, all I would have to do is change this to a plus 2, and it shifts over here. If I want to shift it down, I can change this to a plus 2, and shifts down. And if I want to shift it back over to the right and hit this other quadrant, I could do something like that. So you can see how easy, and if I wanted to be on that center, but I wanted to kind of go across the origin, well, I could make that radius as big as I want. And these values here can be smaller too, right? They could be like 0.5. They don't have to be whole numbers. They can be whatever you want those numbers to be. So now it looks like it's centered on 0, but it's actually centered on 0.5, 0.5. So it's a little bit off in this particular case, right? So you can see how all of these different things affect where this circle is going to land. I'll do y minus 2 again. And you can kind of see how all of this stuff is going to play into this. And now I'll go 2 squared, just kind of fit it back into the screen. 2 squared. And there's a nice clean circle kind of lining up with everything. Now the next thing I want to show you was, what happens when I want to launch the balls, but I want part of them go to the left and part of them go to the right. This example down here with the blocking function doesn't really make any sense. But let's say I wanted these balls, if I had stars over here and I had stars over here, and I wanted let's get a look at something here real quick here. Display 1, and we should be good. Let's say I want part of the balls to go here, part of the balls to go here. I could do something as simple as just saying, what is x equals -2? They're launching from -2, right? So if I put x equals -2, that thing's going to go right across there. Now that may or may not work, kind of worked, but the problem is I can't get on either side of that now, right? So what I might want to do is I might just want to constrain that x equals -2 and say, okay, I'm going to constrain you from, let's say from 6 to 7. So 6 less than x less than 7, and then constrain it again. And so x is bigger, or excuse me, it's going to be y, not x, because now we're looking at the y-axis here, right? So now I end up with this little line here. What this little line is, imagine it's like you're dropping balls, but you're dropping them on, just the point of a stick. Maybe like you're dropping balls on top of a pointy stick. Well, the balls are going to randomly hit on top of that pointy stick, and some are going to deflect this way and some are going to deflect that way. And that should be what we see here. There you go. So now about half the balls, and it's not exact, right? Every time you do it, it could be slightly different. You might get more to go to the right. You might get more to the left. But you are going to get a proportion, over time, you might even be able to get them to stick on top. I doubt that, but you're going to be able to get them to go both directions, which is kind of what we're shooting for here, right? All right, now finally, let's say we want to get up in here to get these stars. I don't know how to get these stars. They're kind of in a really, really bad spot, right? I do remember the equation of a circle, right? So I can say, well, x minus, and it's probably going to be plus, so I want to kind of get down in this bottom area here. So plus 2 squared plus y plus 2, and I'll do a squared on that one as well, equals 4 squared. I have no idea. I'm just throwing a random circle out there. And so what you can see now is you can see my random circle here. Way too big, not what I'm looking for. So I'm going to make the diameter a little smaller. I'm going to go down to a 3. And what I'm thinking I can do is if these balls fall, and if there's like a ramp that they hit right here that swings them back up, I feel like I could throw them back up. So first of all, I need to move this thing a little to the right. So I'm going to do 1, and I'm going to do 1. I'm getting closer, and I really want this thing, the left edge of this circle, to be right kind of where they're falling, just a little bit bigger than -2, right? I'm going to make the diameter of this thing a little smaller yet. And then I'm going to say, okay, well, I need to shift that guy over a little bit. So let me do a 0.5 and a 0.5. Boy, this is getting to be the right idea. Now, what would happen if at this point, if I constrain this function, if I said, you know what, I only want y to be less than 0 or something like that, right? So let's say y is less than 0. Oop, I need to put in the curly brackets here. Y is less than 0. And now I'm going to tell you, this is not the fit I'm looking for. However, the idea is actually correct, isn't it? When I launch these balls, you'll see I already got one of the stars here. Now you might say, well, EJ, a couple things you could do. Maybe you could shift this thing up a little bit. So instead of, 0.5, 0.5, do you want to be at 0, 0? Is that the answer? Do I want to be at 0, 0? Because I don't actually know. So here's 0, 0. Boy, it looks a little nicer. Let's see how that does for me. Ooh, I don't want to do that because what you can see is it's kind of like what we showed before. It kind of hit right on top, right? So I definitely need to shift this thing a little bit to the left. And to shift it a little bit to the left on my x value here, I'm going to have to go x plus 0.5, maybe 0.25. Does this kind of do what I'm looking for? Boy, now we're getting close, right? So you're going to want to play with this and see what can I do to kind of make this thing happen. It might be that you need a bigger radius. I need to catch these things here, and I need to have a bigger radius. So instead of a 2, maybe it's a 2.5. Now instead of a 0.25 for my center, I need to come across a little bit. And so now maybe it's a, maybe it's a 0. Maybe it's, maybe it's a 1. Maybe it's a -1. Maybe it's a minus 0.25. A plus 0.25. It's a minus, right? So here's your plus 0.25. Maybe this is a 3. You can start playing around with this thing a little bit, and before you know it, you're going to come up with something that hopefully you find something that you like. And, this is not the right answer either. However, I almost got to that one. You see, I almost got to that one. I feel like if I narrowed up my radius a little bit, if I changed this 0.25 so I wasn't quite so far in the negative, maybe it's a 0.1, or maybe it is a 0. X minus 0. And let's do the 2.5 here. Yeah, as soon as you start typing in here, then you do a little caret symbol, you get your squared. Then you got to kind of move around to try to get this thing where you like it. All right, x minus 0, x minus 0.25. Boy, this is looking pretty good. Let's check it out. I hate to say it, but through a lot of trial and error and just understanding how the circle function works. And I should be careful here. It's not circle because it's not a function. In this particular case, it's a semicircle, which is a function. A circle would be an equation, but would not pass the vertical line test. But what we can see is we've got this thing kind of dialed in now where we can actually launch these balls in one direction and send them back up to get balls from a different direction. And you might say, well, wait a second, I want to put this thing above the axis. So instead of, y plus 0, let's do y minus 2, and then instead of y less than this, maybe it's y less than 3 or y less than 2. Now all of a sudden I'm getting even, more launch off this thing where it's kind of like a spiral growing upon itself. So if I change this value, if I go to, plus 1, so now it's 3 spots different, I'm going to have to go the same here. Now, I don't think I'll get there with this because this is a much steeper. Well, look at that. I'm throwing them a lot further up in the air, though, as you can see. So it's kind of interesting to try these different things and kind of go for it and see what these different things can do. So the big difference with this week's homework, you're going to have functions where you need to push balls in 2 different directions, which I've shown you how to do just by using the point of a line. You're going to have functions where you're going to have to throw balls up in a different direction to get up into some other area. So you're going to have to kind of defy gravity a little bit here. And so what you'll do is the same thing as what you're doing. I'm going to publish homework 4. There will be 3 elements in homework 4, just like the previous ones. And the goal in all of these elements is to get as many of those stars as you can do. So click on that link. You do not have to create a login. You can just continue without signing in. And then make sure when you submit that homework that you do post those equations for your solutions into the Word doc, and then just post the Word doc to Canvas. And I will use that to grade this week's or this module's homework. So if you have any questions, again, reach out to me on email or on Teams. Thanks.